Okay, welcome to 6.2. This section is pretty difficult. There's a lot of things you need to know, so let's just start. The first thing you need to know is we're really looking back to the stuff we learned about in 5.1. So if any of this seems unfamiliar to you, you may want to go back and watch the 5.1 video as well. But let's get started. So the first thing is when you multiply the same base together with different exponents, you add the exponents up, so 5 to the 1/2 times 5 to the 3/2 equals 5 to the 1/2 plus 3/2 equals 5 squared equals 25. The second one, when you take an exponent to an even higher exponent, you multiply, so that's how you got 3 to the 5/2 times 2, which is equal to 3 to the 5ths, which is equal to 243. In number 3, if you have two numbers being multiplied together that aren't the same, and they're being taken to an exponent, you can distribute that into both of them. You multiply it into both of them. So what that means is 16 to the 1/2 times 9 to the 1/2. Remember, to the 1/2 power is the square root, so square root of 16 times the square root of 9, 4 times 3 equals 12. Number 4. If you take something to a negative exponent, of course you flip it. 1 over 36 to the 1/2 is 1 over 6. That one's pretty easy. Number 5. If you're dividing the same base, 4 divided by 4, with different exponents, you subtract those exponents. 5/2 minus 1/2, you get 4 squared equals 16. And the last one, if you have two numbers that are not the same being divided, taken to a certain exponent, you can distribute that to both of them. 27 to the 1/3 is 3, 64 to the 1/3 is 4. Your answer is 3/4. There's a lot of different things you need to know, and these are going to come up throughout the practice problems and throughout these examples, so you may want to write these down. These are really the most basic examples, and it only gets more difficult from here. Let's look at some examples. I chose 5 from the textbook. So the first one is 7 to the 1/4 times 7 to the 1/2. You add the exponents up, so you have 7 to the 1/4 plus 1/2. And 1/2 is the same as 2/4, you have to remember. So 7 to the 1/2, or to the 1/4 plus 2/4 is 7 to the 3/4 power. And the text is fine if you leave it in that form. Of course, you know that 7 to the 3/4 power means 7 caret to the 3/4 if you want to calculate a decimal answer, but you don't need to do that. The text is fine with that. Second one, 6 to the 1/2 times 4 to the 1/3 to the second power. Those bases are not the same, so we can distribute this 2 inward. And even if the bases were the same, we could distribute it inward. Let's just do that. So 6 to the 1/2 times 2. Remember, a power to a power is not adding them, it's multiplying. 6 to the 1/2 times 2 is going to be 6 to the 1. 1/2 times 2 is 1 times 4. 1/3 times 2 is 2/3. And the book's actually fine if you leave your answer like this as well. Or, of course, you don't need that exponent of 1, so you have 6 times 4 to the 2/3, and that's going to be your answer. You can't really combine those anymore. Okay, the next one. 4 to the 5th times 3 to the 5th to negative 1/5. Once again, taking it to a power, distribute it in. 4 to the 5 times negative 1/5. I'm going to go ahead and write this one out for you. So 5 times negative 1/5 times 3 to the 5th times negative 1/5. So 5 times negative 1/5 is negative 5 over 5, that's negative 1. Times 3 to the negative 5 over 5, 5 times 1 is 5 over 5, is also negative 1. Of course, you move those both to the bottom. 4 to the negative 1, 3 to the negative 1. You can just multiply, or sorry, that negative should actually be positive now. I did that incorrectly. So 1 over 4 times 3, which is 1 over 12. Okay, the next one. 5 over 5 to the 1/3 we're dividing, this is really 5 to the first power divided by 5 to the 1/3 power. So we're going to subtract those exponents because we're dividing. So 5 to the 1 minus 1/3 is equal to 5 to the 2/3 power. Because really 1 is 3/3. You get 5 to the 2/3 power as your answer. And the last one. This one's a bit trickier. If the bases are different, but the exponent's the same, we can separate it out so it looks like this. 42/6 to the 1/3, because we would distribute that in. And then all of that to the power of 2. 42 divided by 6 is 7. Keep everything else the same. 7 to the 1/3 to the power of 2, which is 7 to the 1/3 to the power of 2. That means you multiply the exponent 1/3 times 2. So you get 7 to the 2/3 power, and that's your answer. We just looked at properties of exponents, and now we're going to look at properties of, so for example, if you have the cube root of 12 times the cube root of 18, you can multiply what's inside there together, so 12 times 18, which is 216. That's still under the cube root sign. You take the cube root of 216, and you're going to get 6. Now, if you want to change those to exponents, you actually could. Remember, that's 12 to the 1/3 power times 18 to the 1/3 power. When the bases are different, but the exponent's the same, you can put it together like 12 to the times 18 to the 1/3, 216 to the 1/3 equals 6. So it's two ways to do it. You can do it with radicals, or you can change it to exponents and then just follow the properties for exponents. Okay, when you want to add and subtract radicals, you can think about this part as a variable like x or y, and you cannot combine them through addition or subtraction unless they're exactly the same. Here they are the same, 4 root 10 and 4 root 10. So what we have here is 1 4 root 10 plus 7 4 root 10, which gives us an answer of 8 4th root of 10. In this second example, we cannot combine those, they're completely different. So we need to change this one until it looks like this. Right now it would be like trying to subtract x and y, it just wouldn't work. So the cube root of 54 is really the cube root of 27 times the cube root of 2 minus the cube root of 2. So I broke that up into two parts, 27 times 2. The cube root of 27 is 3 times the cube root of 2. Now we can combine them. 3 cube root of 2 minus 1 cube root of 2 gives us an answer as 2 3rd root of 2. Okay, I really don't want these videos to be more than 10 minutes, and this one's already getting really close. I've already talked to you about a lot of new material. There's some things which I haven't talked about, which also may show up in the practice problems. So I'm going to refer you to pages 420 to 423 in the Unit 2 book. Some of the examples I did are in there, but there are some other sections as well that may be useful to you. But of course, you can always refer back to this video as well.